Section 4, Video 4. Here we have an inequality that is not linear. The power of 2 makes it quadratic. So if we were to graph this, we would graph it like we normally would a quadratic where we don't know a lot of information. We would do an XY table. We plug in -2, -1, 0, 1, 2. Let's go a little bit more here. We'll go 3 and 4. If we plug a -2 in, we would get 15. And again, to clarify, that means I'm taking a -2, plugging it into the function, and seeing what I get out. In this case, I get 15, and I get a 5 with a -1. 0 would give us -1. 1 would give us -3, again, just by plugging it in. 2 gives us -1. 3 gives us 5. And 4 gives us 15. So the first point that I can actually graph would be -1, 5. 0 gives us -1. 1 gives us -3. 2 gives us -1. 3 gives us 5. And there's your symmetry. Now, just like with graphing linear inequalities, we have a decision to make. Will it be solid or dotted? There is no line underneath it, so it is dotted. So I graph the parabola with dotted lines. I also have to decide what the shading is. Now, unlike a linear equation where you would shade one side or the other, with quadratics you decide to shade inside or outside. But the one rule still applies. If it is a greater than, we shade above. But when it comes to above with a quadratic, it's really interpreted as in. So if you consider the quadratic to be a bowl, you would shade inside it, and that would be considered above. Again, you can plug in a coordinate to see. So if you chose 0, 0, and you go 0 is greater than 2 times 0 squared minus 4 times 0 minus 1. We've already plugged that point in, and we get a -3. Is 0 greater than -3? Yes, it is. That coordinate is inside the cup, per se, of the quadratic, so we would shade inside it. And this ends Section 4, Video 4.